Alright, this is our video on section 2.2 on linear equations and functions. Now, a linear equation and a linear function, they're pretty close, they're pretty similar, about the same thing. There's one major difference. So I want to go through what a linear equation and what a linear function are. A linear equation is any equation that, when graphed, makes a line. Alright, that's what it means. If I had something like y equals x plus 1, that's our example from the 2.1 video. We graphed that, it made a line. That's a linear equation because it makes a line. Linear function has the same basic idea here. Any equation that, when graphed, makes a line and is a function. The reason we add that little stipulation into it is because if I had a vertical line, technically that's a linear equation. I made a line. It's a vertical line. I graphed it. But it's not a linear function because it does not pass the vertical line test. Okay? So that's really the only exception. A vertical line is not a linear function. That's really the only one that doesn't count. Because if it had a positive slope, a negative slope, or a horizontal line, all of those would still be functions. They'd pass the vertical line test. But a vertical line can't pass the vertical line test because they'd be the same. It would intersect at more than one point. Okay? So what we're talking about today are linear equations and linear functions. There are a few rules. And these are rules for linear functions. Okay? And equations that go together. Linear equations and linear functions. Alright, rule number 1. This is if I'm just giving you a problem, and you can tell by looking at the problem whether it will make a line or not. Rule number 1. Can only add, subtract, or multiply a variable and a number. And what that means, the stipulation here, is that you cannot multiply variables. Okay? Now, I do want to point out that you can divide as long as your variable is in the numerator, and that's rule number 2. Okay? Variables cannot be in the denominator. This is not acceptable, 2 over x. If I had this, though, x over 2, that's really 1/2 times x, which goes back to the first one. I can multiply a variable and a number together. That's what I'm doing. I have 1/2 my number and x, my variable, I'm multiplying them together. So this is okay, but this is not. 2 over x. Cannot have a variable in the denominator. Last rule here. No variables with exponents other than 1. Okay? Our exponents through all of these on the variables has to be 1. I can have an exponent on a number because it will still be a number. I just can't have a variable other than 1 on, an exponent other than 1 on a variable. And those are our 3 rules. Our examples here, I'm going to have you go through and check whether these are linear functions or not. You need to make sure that each of these meets the rules that I just gave you, those 3 rules at the top. So our first one is 5x minus 3y equals 7. If we look there, I'm only multiplying numbers and variables. I'm not multiplying variables together, so that meets rule number 1. Rule number 2, variables cannot be in the denominator. I have no fractions, so that's fine. And my exponents are all 1 on my variables. They're not written, but it's understood that they're a 1. So yes, this is a linear function. It meets all those requirements. I want you to go through real quick, pause the video, these are your practice problems, and check the rest of these. See if you can figure them out on your own. It's pretty easy. Now, if it's a no, be sure you can explain why. All right? But do these other 5. All right, let's go through these. The second one here, 7x plus 4y squared equals negative 8 is a no because of the exponent of 2. Exponents can only be 1 on these problems. Our third example here, x plus x times y equals 21. This one's also a no because you are multiplying variables together. That can't happen. Our next example, 2 divided by x equals 45. It is a no because I'm dividing by a variable, and we've said that in rule number 2. You cannot divide by a variable. Now the next two are where I get people. This is a little tricky. F of x equals 4 plus 7x. Most people would tell me no because of this. It's f times x. Well, this is actually yes. Remember I told you we learned about function notation? F of x, it's really just y. I could make this y equals 4 plus 7x. And that's okay. That's my problem. It's the same thing. So don't get hung up on this, where we have f of x. It's okay to have that. Remember, it's just the name of the problem. Let's look at our last example here. P of x, we just said that's okay with f of x. So if you said no for that reason, that's not right. Equals x cubed plus 3. This is a no, but it's a no because of the exponent. The exponents are 3 here. All right? So there's those examples. Make sure that you understand why you got them wrong if you got them wrong. Okay? Next thing we're going to talk about is standard form. Standard form for a linear function is a times x plus b times y equals c. You'll see that a lot. That's standard form for a linear function. And there are a couple rules for it also because you're going to be asked to determine a, b, and c in a lot of these problems. First one is that a, b, and c are numbers. Okay? They should have values. They're not going to stay variables. If they're variables, then it's automatically and you can't figure it out. Okay? It would be no, it's not a function because you'd be multiplying two variables together. So a, b, and c, first of all, have to all be numbers. Now, 0 is a number, but a and b both cannot be 0. So either one of them could be 0, but they both can't be 0 at the same time. If they're both 0, then I get rid of both my x and my y, because 0 times x would be 0, 0 times y would be 0. So one of them can be either a or b, but both of them not at the same time. Our next rule is that a should be greater than or equal to 0, which just means it needs to be positive. Should be a positive number. If it's not, we need to change that. You cannot have fractions. And your greatest common factor should be 1. Alright, we got an easy example here. 2x minus 3y equals 24. It meets all of our rules. A is positive. A and b, neither of them are 0, which is okay. There are no fractions, and the greatest common factor between my a, b, and my c is 1. So if I was going to list it out, I would say a is 2, b, and this is catches some people, is negative 3. You need to take the sign with it. And c is 24. So there'd be my answer. Okay, we've got two examples, and what I want you to do is determine A, B, and C. And I'm going to leave it up to you. You can try it on your own. If you want to pause it and then come back and check, you are more than welcome to, but I'm going to go ahead and work them out. So it's up to you whether you want to follow along or try it on your own. With our first example here, we have negative 4 equals 7y minus 20. Now, this is standard form, remember. ax plus by equals c. X and y have to be on the left-hand side together. So what I'm going to do is I'm going to subtract my 7y. And that gives us negative 4x minus 7y equals negative 20. Now most people would stop there. Well, not most people. This is where I catch some people. they'd stop right here and tell me that A is -4, B is -7, and C is -20. That can't work because A has to be greater than or equal to 0. It needs to be positive. And it's not. It's negative at this point. So what we're going to do is we're going to multiply through by -1, which essentially just changes all of our signs. So it becomes positive 4x plus 7y equals positive 20. So now I know my A is positive. A and B, neither of them are there. Well, neither are 0, which is fine. There are no fractions. And the greatest common factor between 4, 7, and 20 is 1. So I'm good. I can go ahead and list these out. I know my A is 4, my B is 7, and my C is 20. Now, one other place where I catch some people is that when we multiply through by the -1, it needs to go to both sides. Some people will tell me that it's negative, C is -20. Make sure it goes to both sides. Since it's an equation, whatever you do to the left side, you have to do to the right. All right, let's look at example 2. We have -2/3 x equals 2y minus 1. Same idea we started with on the last one. X and y need to be on the left together, so let's subtract 2y. And we are left with -2/3 x minus 2y equals -1. Now we got some problems here. A is negative, and we have a fraction. So what we're going to do is we're going to get rid of that fraction. We're going to multiply by a denominator of 3. Whatever the denominator is, I'm going to multiply that through, just like I did the -1, and it's going to get rid of a fraction for me. But I have to do it to everything that's on both sides. Now I'm going to combine this and make it a -3. And by making it a -3, I'm going to make my A positive. Okay, you can do it in 2 separate steps. Multiply by 3 and then go through and do a -1. But I can do them together. It'll save me a step of work. And I'm going to distribute this. So right now I have -3 times -2/3. I'm going to write this just so you can see what's going on. Okay, my 3's cancel, and they both become positive. So I'm left with 2x. I've made my A positive, and I've got rid of the fraction. That's what I want to do. The second one here is -3 times -2, which becomes positive 6y. Now my -3 has to go completely to the other side of the equals sign. -3 times -1 is positive 3. So now I've got 2x plus 6y equals 3. That looks good. And all of them have the only greatest common factor is 1. So I'm good to go. No more fractions. A is positive, and the greatest common factor is 1. So my A is 2, my B is 6, and C is 3. Now, I will say both of our examples here came out with all 3 of them being positive. It is okay for B and C to be negative, just not A. All right? The last thing we're going to talk about are intercepts, and we're going to go through this pretty quick because it's something you should already know. Intercepts are the points where an equation crosses the x or the y axis. If it crosses the x-axis, it's an x-intercept. If it crosses the y-axis, you guessed it, it's a y-intercept. Okay? Now the form for those, our x-intercept should always be whatever our value for x is, the number where it actually crosses, in 0. So it's x comma 0. Our y-intercept is the opposite. Since it's moving up and down, our x should be 0. It's not going to go anywhere on the x-axis. It's only going to move on the y. And our y should be a number. Okay? To solve those, if you've got an equation, whatever you're finding the x-intercept or the y-intercept, you plug in 0 for the opposite. So if I'm finding my x-intercept, I plug 0 in for y. If I'm finding my y-intercept, I plug 0 in for x. Now if I have a graph, then I can look off my graph. That's easy. That's the easy type. But if I don't have a graph, then I have to plug in my zeros. Okay? So we've got an example. It says determine the x and the y intercepts. Our problem is -2x plus y minus 4 equals 0. So let's start with the x-intercept. For the x-intercept, we plug 0 in for y. So -2x plus 0 minus 4 equals 0. simplify some stuff. Negative 2x minus 4 equals 0. We can solve it from here. Negative 2x equals positive 4 because I add 4 to both sides. Divide by negative 2. So x is negative 2 because 4 divided by negative 2 is negative 2. So when I list it out, my x was negative 2, and then y was 0 because that's what I plugged in for it. Now let's do the y-intercept. Same idea, except I'm plugging 0 in for x. So negative 2 times 0 plus y minus 4 equals 0. Simplify it, that cancels. 0 times anything is 0, so we have y minus 4 equals 0. Y equals 4. Write it as a point. I plugged in 0 for my x, and my y value was 4. So there's my x-intercept and my y-intercept. Now those are your notes for section 2.2. It's an important section. It's pretty random. There are several different ideas going on, but it's an important section, so if you have any questions, be sure you bring them to class.